Hi, I'm Matt, and in this video we are going to go over metric units and how to convert between them. So first, what exactly is a unit? Well, a unit tells us what something is measured in, and there are different units for different types of quantities, such as seconds is a unit for time, and kilograms is a unit for mass. There are different types of units that we are going to talk about. The first type is a fundamental unit. These are the most basic units in the Système International or SI system of measurements. All other units are derived from the 7 fundamental units, which are the second, which measures time, meters, which measures distance, kilograms, which measures mass, amperes, which measures current, moles, which measures the amount of a substance, the candela, which measures intensity, and Kelvin, which measures temperature. In this course, we're not going to worry too much about the ampere or the candela, but the other 5 will be very important. One final note about fundamental units is that conversions between fundamental units can't be made. We can't convert meters to seconds because that just wouldn't make sense. You wouldn't say, my bed is 5 seconds away. Also, while we can't convert, we can combine them to make complex units. So once again, complex units can be formed by combining the fundamental units. Some examples are velocity, which is measured in meters per second, momentum, which is measured in kilogram meters per second, and molar mass is measured in grams per mole. Now, while complex units are helpful, sometimes they become long and tedious to work with, so we use a derived unit, which is where we choose a different letter to represent it. For example, we use newtons for force, and a newton is the derived unit for kilograms meters per second squared. Another example is the joule, which is the derived unit for energy, with a joule being a newton meter or a kilogram meter squared per second squared. It just makes things more simple when we do our math. Now, the last thing we need to go over before we start conversions are prefixes, such as kilo and milli are used to help us represent big or small numbers. Rather than write that long decimal in meters, we could write it in picometers because all of those zeros makes it 1 picometer. And conversion factors are often supplied on reference tables. So let's look at some of the conversions we're going to be using. So in this chart, on the left, I have the conversion factor, the middle, the prefix, and on the right, the symbol. You'll realize I have that boldface term base. That's 10 to the 0 or 1, and that's our base unit, or the unit everything is relative to. So kilo is 10 to the 3rd, or 1,000 times larger than the base. Deci, centi, milli, micro, nano, and pico are all smaller than the base, which is why they have a negative exponent. We're going to be using these prefixes throughout the lesson, so you might want to quickly copy these down or Google a quick table to guide you. So in chemistry, we're going to use something called the factor label method to help us convert, and we're going to use these prefixes as our conversion factors. So you'll see we're going to use the form where we have our initial unit multiplied by our desired unit divided by our initial unit. And that desired over initial is our conversion factor. So before we try one, let's look at an example. Here we converted 20 milliliters to liters. So our initial unit is milliliters and the desired unit or the unit we're going to is liters. So first, we could just fill in what we're given for our first initial unit. So we're given 20 milliliters. And then we need to set up our conversion factor. So the factor, or the parts with the exponent, will always go to our base unit. Here we have milliliters, and milli is 10 to the negative 3rd. So you see on the top of the fraction, I put 10 to the negative 3rd liters because it's the factor and the base. And then on the bottom, I put 1 milliliter because that's equivalent to 10 to the negative 3rd liters. And then lastly, I just plug this into a calculator to get 0.02 liters. So now let's try one together. So we need to convert 50 grams to kilograms. So our initial unit, or what we're given here, is grams, and our desired unit is kilograms. So now, plugging in, we'll get that we have 50 grams for our initial, and then we have to set up our conversion factor. Remember how the exponent, or the scientific notation piece, always goes with the base. So kilo means 1 times 10 to the third. So we're going to have 10 to the third grams. And then we put the 1 with the other unit. So our conversion factor here would be 1 kilogram over 10 to the third grams. And when we multiply that together, we get that at 50 grams equals 0.05 kilograms. Now, all of our prefixes are relative to the base. So if we're going from a non-base unit to a non-base unit, such as kilo to milli, it is best to do it in 2 different steps, where in the first one we convert to the base, and then in the second one we convert out of the base. So let's look at the example where we converted 1 kilogram to milligrams. So we start with kilograms, and we want to go to our base unit, which is grams. Using our chart, we find that there are 10 to the third grams in 1 kilogram, so that's our first conversion factor. And our second conversion factor is that in 1 milligram, there are 10 to the negative third grams. And when we multiply this, our kilograms cancel out, and our grams cancel out, leaving us with 1 million milligrams. Now, let's work through one of these together. So we want to convert 43 decimeters to kilometers. So we first put our initial, or what we're given, which is 43 decimeters, and we want to convert it to kilometers. Looking at our chart, we find that there is 10 to the negative first meters in 1 decimeter. Then we need our second conversion factor, which is to go from meters to kilometers. Once again, looking at our prefix chart, we find that there are 10 to the third meters in 1 kilometer, and then we multiply through to get 0.0043 kilometers. You'll realize how even though we're doing it in 2 steps, the exponent, which is the 10 to the negative first, or the 10 to the third, still goes with our base unit. Now, the last type of conversion question we have to go over is when we have a complex unit and we have to convert both the numerator and the denominator, such as if we had 6 kilometers in 1 minute and we want to convert it to meters per second. So we have to convert each individually. So first, I would always deal with the numerator. So we have 6 kilometers and we need to go to meters. So we would put meters on top since that's the desired unit, and kilometers on the bottom since that's what we have. Using our prefix chart, we get that there are 10 to the third meters in 1 kilometer. Now, for our second conversion factor, we need to convert minutes to seconds. So we have minutes on the bottom, so to get it to cancel out, we're going to have to put minutes up top. And then we would have to know how many seconds are in a minute, which there are 60 seconds in a minute. So our second conversion factor is 1 minute and 60 seconds. And multiplying through, we get that 6 kilometers per minute is equal to 100 meters per second. So now, let's try a practice question. So we want to convert 27,000 watts per minute to kilowatts per hour. So first, I would write it as a fraction, 27,000 watts over 1 minute. And then we have to find our first conversion factor. We're given watts, so we would put watts on the bottom and then kilowatts up top. Using our chart, we get that there are 10 to the third watts in 1 kilowatt. So we put 1 over 10 to the third. And then we need to convert minutes to hours. To get minutes to cancel out, we will put minutes up top and hours on the bottom. And there are 60 minutes in 1 hour. Once again, we still put the factor we're multiplying by with the base unit. and multiplying through gives us 1,620 kilowatts per hour. Now that we've gone over all the types of problems, here are 4 questions. I encourage you to pause the video and try them. The first one is going from meters to millimeters. The second one is going from kilojoules to joules. The third is going from milligrams to kilograms. And the fourth is going from kilometers per minute to meters per second. The solutions will be provided for you on the next slide. The solutions are as follows. 5 meters equals 5,000 millimeters. 6 kilojoules equals 6,000 joules. 3,500,000 milligrams is 3.5 kilograms. And 7.2 kilometers per minute is equal to 120 meters per second. Hopefully you got these. If not, feel free to leave any questions you have in the comments below. Thank you so much for watching. Have a great day.